future hand in hand in this tech-driven wonderland.
Hi everyone, this is episode 30 of Near AI Office Hours. And today we have Eugene from a project called, I'm afraid to mispronounce it, RWKV.
Yeah, you got it right. So for most people in America, I actually prefer to say RWKV, receptive key value, which is a play on the famous transformer QKV. Because every time I say Roku, people keep thinking, "Are you Roku TV?"
Yeah. Okay, so RWKV is it's an alternative architecture. I don't know if you guys still call it a transformer architecture, right? That primarily, so initially when I looked into it, I thought it only replaces the attention, but it replaces all the components of the transformer, right? Including the feed forward.
So for the full RWKV model, we actually replace all the components for it. For the converted variants, like the QRWKV, we do keep the feed forward from the transformers. But I think those are like more towards the technical details because like some of the core blueprints are still the same. Like we are once you look underneath the layers, it's still matrix multiplication, CLOOK activation functions. Those things are still the same.
Yeah. Cool. So there's a couple exciting things to discuss here. So one is that, so my understanding is that RWKV, so there are generations of it, right? And we're generation 7, right? And each of them,
Coming one. 6 is the main line right now. Where 7 is probably going to be dropped soon.
yeah, and yeah, very much like Ubuntu versions, they all called after a animal or a birdie. That is starting with the right. So we're getting into the goose, so there's a PDF that explains versions 5 and version 6, and I presume there's another PDF that explains the previous ones, but I didn't see that one. I only read the one.
Yeah, there is
explains
also a
five and six.
there's no PDF for version 3, 2, and 1 because we didn't write papers during that age.
Yeah, and so the PDF, I don't know if it's available from the website, right? So there's a website which is rwkv.com. I don't know if there's a link to PDF from here. But yeah, if anything, we will post it together with on Twitter and YouTube so that people can see it. So there's a couple. I guess there are a couple questions to start with. One is, can you? I think one interesting thing to explain here is what is the structure of the project, right? Right? Who's driving it? How many people are involved? How they communicate to each other? I think this is a very interesting. Effort.
So I think one of the things that makes RWKV very unique and actually confuses the heck a lot of people in AI, right, is that we are driven more like an open source software than anything else. So typically in AI space, right, people will have a hypothesis and then they'll draft a paper and then they will do the experiments and then they will do the results. So it's always like things will be released more in the sequence of paper, model artifacts, weights and code in that sequence. Ours is, as with any open source project, right, is the code is actually in the GitHub repo. It is being iterated live. The reason why some people already know about V7 is because the V7 candidate code is already in the GitHub repo. And these things so there's one channel called RWKV Dev where we actually allow people to propose experiments and experiments get run. Is that when new ideas can be introduced and in a collaborative way, and if a core member picks it up, do a run and thinks like, hey, this actually improves the model. Congratulations, it's a candidate for the next version. It's one of the candidate mergers for the next version, and that's how we've been actually building up on the RWKV project since essentially version 1 or 2, like where we showed that the core idea was that, hey, if you take something like an RNN structure, but if you remove the bottlenecks from it and you scale it up using the same matrix multiplication and serial activation functions techniques that we see being used in transformers. We could re-engineer this architecture to be extremely scalable at transformer level, while still be extremely compute efficient like an RNN. And after we solidify like certain key ideas, right? Like one of the things that I say is that no component or idea is sacred. We have ran experiments where we remove or replace entire core components, just to see whether it works better, and that's led to the iteration from V2 to V3, V4, V5, V6, and V7. So in terms of like community contributions, right? In terms of the foundation model side, right, the core contributions is only around like, I guess we'll say like 8 to 10 people, we give and take. Some more active, some, hey, as with any other open source project, have not seen you in half a year and then suddenly see you again, kind of situation. And we contribute the ideas, and the core members will try to train it and iterate on it, and so on. But beyond the core model, the core team is being led by co-led by me, Blink DL, the original creator from version 0, and Harrison Vandervelde, who's another core committee member. Beyond this core group that works on the foundation model itself, there is an extended group as well that works on the inference code, the data sets, and basically things within the ecosystem. So that's how like this project like balloons from like 10 core members to like 20, 30 additional auxiliary contributors, and over 800 members into our Discord community itself. So
Mhm.
sorry, 8,000 members. So that's the structure for the RWKV organization.
Yeah. And so, but by the way, you mentioned that you remove the whole components, which is I guess exactly what happened when the transformers were created, right? Because I think before transformers were published, it would be blasphemy to think about removing recurrent connections from RNNs, right? But they removed the whole recurrence there. And so with RNNs, right? So with RNNs, we have each token depends on the previous one, right? And so you go from left to right. And so historically, before transformers, RNNs were very hard to train in parallel because you had to go one token at a time at training time, right? So transformers changed that so that now you can train on the whole sequence. Right? But at the same time, transformers are at the inference time, you pay penalty because you have quadratic attention, right? And so my understanding is that RWKV has a construction which you can compute both in parallel during training, but then you can sort of reformulate it in the way that it is recurrent, right? Is it correct understanding or?
Yes, it's correct understanding. But I think it's also part of like one of the one of the key things that we broke the bottleneck line. So if let me see whether I can share my screen. Am I allowed to share screen? Yep. Okay, I'm going to quickly share screen. So I'm not sure how many people is it will be able to see it, but it's like the one way I view it is that like every model, be it transformer or RNN, at the end of the day, right, is just lots of layers with embeddings flowing in whatever directions, and we just stack them. So that's the core argument we're making. The big leap for AI, right, was not attention is all you need. It's actually more of like we have figured out how to scale matrix multiplication to billions of parameters, and so the if you remember the ORNN structures, right, is that the biggest bottleneck, right, is that your embedding from the last layer will need to be fed to the first layer in the second token. So the first token, as the outputs come out, the last output will need to be fed to the second token, and then it feds again. This made every single token need to be wait exclusively one after another, and that caused the very slow bottleneck. So what ended up for people is that you have your H100s. Okay, it wasn't H100 at that time. Times have changed a lot. But you can have a H100, but if you need to do things step by step, right, it was extremely slow. Why we fundamentally change is that if you want to oversimplify, is we remove that line. And once you remove that line, right, the computational process, right, can happen in a cascading pattern. So once the very first inference block is computed, so for example, like so once you remove that line here, and the first inference block is computed at the start, it cascades very rapidly, and this is like within the first 3-4 tokens, you can start saturating the GPU because of the cascading pattern. This may not be exactly how it runs, because you can think of blocks as chunks or GPUs or layers, because it's apparently more efficient to do that when you write the actual CUDA kernel. But from a visualization standpoint, right, once you are past the first few tokens, you can cascade, and you no longer have that sequential weighting bottleneck, and that essentially allow us to scale a lot of our training or even inference, because even on inference, we can apply these techniques for pre-filling and to generate the state rapidly.
Yeah. So here, axis is context and y is layers, right?
Say again?
So x axis is that's the context, right?
Correct.
And y axis is layers.
Then the other one is layers. Yes.
Yeah. Yeah.
Okay. Stop screen. Yeah. So so like the general principle as we scale or do iteration is that it must not compromise on the compute bottleneck, and it just needs to improve better the model, and we iterate on that. So we somehow have kept this cascading structure, where information flows up and to the right, because it's the main way to ensure that we have a fixed state between tokens, but in a way that is structured that can saturate a GPU.
Mm-hmm. Yeah. And so there's a 34 billion parameter model trained with this, right? That's version 5, right?
So for version 5 and version 6, we only train from scratch, though we are stretching the definition from scratch here, because some of it is converted from older versions of RWKV, or up to 3 trillion tokens, up to 7 billion parameters. Then we upcycle it to 14 billion parameters. So those are like our mainline RWKV models, that is trained on over 100 languages. And this is also one thing that's interesting for RWKV, because we are a very community driven approach, and we actually work with a lot of people from different nations. We actually focus very heavily on multilingual from the early get-go. Our tokenizer is a completely different tokenizer. Yeah, it's what we call the world tokenizer, and it was trained specifically on the top 100 languages, according to Wikipedia. And so we intentionally train it on multilingual from the get-go, and the data set that we use is also reflective of that. And this also makes us ends up like being one of the top ranked model in a lot of foreign evals and test set, specifically for different languages, only because we actually work with native speakers for their languages. Though sometimes this is like more like a case of like, hey, we might be the only 3 models that support the language kind of scenario. But that's the thing. Why we do that is because we want to make AI accessible to everyone. So, and this intentional direction, right, actually hurts our English eval, but it's not something that we are obsessed over. We are actually more like focusing on like multilingual. Yeah, and that's for the core RWKV models. But for the QRWKV model, which we recently launched, so based on the V6 architecture, that is not part of our main line. That is an experimental preview version where we took Quen32B, and Quen32B unfortunately is only trained on, from what I remember, either 15 or 20 languages. And it was an experiment where we froze the feed forward layers, replaced the attention layers with RWKV, and then we trained the attention layers to replace the original quadratic attention. So this brings about and somehow it worked. That was a crazy thing. It's like I sound like I'm explaining a Frankenstein experiment where I deleted half the brain and insert a new brain on it. But during the training, with just a few million, 500 million tokens, we were able to like fix the attention layers, and we realized that it worked. And the big benefits of this is that it ended up being one of the best linear model, and that is exciting because transformers are expensive to run because of the quadratic nature, especially over long context length, or if you want to do O1 reasoning. And this is because like with every token you output, you need to expand the amount of memory space and compute space. So if I were to use a human analogy, that's a little bit absurd because like basically for every second you need to leave, your brain needs to expand. So if that was true, like if you're 10 years old, the brain would have exploded. But the thing is like somehow we managed to get that to work in transformers and through brute force of the computation we have. And to me that's something that doesn't make sense. And if we are able to like scale it down to a more fixed state size, it'll be much more efficient. And that is essentially what our architecture does. So even though the converted model is still, we only replace the attention layer with RWKV, and we don't use RWKV's feed forward layer, which we call channel mix. So it is still able to retain most of the benefits that we have from RWKV without the upfront training cost, essentially. And this is a paradigm that we are still exploring and scaling as of now. We are converting the Llama 70B, and we are actually looking forward to that because if that converts successfully and works with 32K context length, as far as we know, I don't think most enterprises 90% of workload is can be serviced with this model. And if that's the case, right, if most AI workload can be done without quadratic attention, is attention all you need anymore?
Well, you can still, I would say it is still attention, right? It's just no longer quadratic, or
Yeah,
you
it's
wouldn't
self-attention.
qualify it as an attention at all.
Yeah, this is a back and forth debate. It's like, is self-attention considered attention as per the paper? And I'm like, okay, I can leave that to someone else to debate it.
Yeah, yeah. And so I think you mentioned it, but just to reiterate, so first of all, the resulting model it is competitive with the original Qwen, right? So it's but the inference time now is noticeably faster, right? Because you don't need, I guess it's not just faster, but you don't need to store the KV cache, right? So it's also much more memory efficient relative to regular quadratic attention. And the actual V6, right, we mentioned at the very beginning, so V6 both replaces attention and the feed forward. But in this case, the feed forward is still just a math move, right? So you don't use the feed forward changes that you introduced in V6, only the attention, right?
Yes, exactly. So we keep the original transformer feed forward in this case.
Yeah, and it's so I think it's interesting. And the feed forward is frozen for the entire duration of training, right? You don't unfreeze it at the
No,
end.
we to clarify. And so it's a two-step process. The first step is you need to freeze the feed forward network to initially train the new attention layer. Even that is not sufficient because it's like if you as a protocol, like the attention layer has a certain communication protocol with the feed forward layer, and then after that you need to unfreeze the feed forward layer with a custom learning schedule, which we are still kind of like tuning for best results, to ease the integration between the two sets.
Yeah. And okay, so I have a couple more questions about the tech itself. So I think one thing I found interesting is that each version introduces new interesting concepts, right? So it's interesting that 5 and 6 are described in the same paper, right? So it's every advancement. Right, and there's already, so on the website there's already explanation of 7, and 7 like even just by comparing the visual representation of 7 to 6, 7 looks definitely more sophisticated, right? So it's getting. I'm curious. So one thing about 7, I'm curious if it uses. It mentions that it trains something at test time. I don't know if you know the deep details of what exactly is happening there.
Oh, okay. There's too many things that happens. So one of the things, benefits and curse of open source community. Benefit is nothing stopping various members of the team going into various direction, and sometimes the experiments can go faster than the results. So like So one of the things that I'm sorry to our own internal RWKV MOE team, because we were actually also doing an MOE model, and we announced it on we in the end announced it on the same day as the QRWKV model, but no, I'll be honest, no one's going to pay attention to the MOE model because the QRWKV model performance jump is so huge compared to the MOE model. It's like the MOE model is not relevant. Yes, and that's kind of like how also part of how we run. The reason why V5 and V6 paper came out together is because by the time we were done with the V4 paper, we were already at V6. Kind of situation. So it was like, hey, okay, let's do both paper at the same time. And yeah, so it's like there is that step jump. So like I would say like in terms of like historically, right, the big jumps that we had, right, was from V3 to V4. Then V5 is an incremental of V4. Then V6, V5 and V6 is kind of like increments, and then V7 is a huge jump from V6 itself, and yeah, and hence the diagram got changed dramatically. It's very but if you see everything right, it's still kind of like hold a lot of lineage down to even like V2 or V3 because it's still incremental ideas being built on top of each other. Through experiments. As for like test time, test time inference compute, right? So there are two things that makes our architecture very favorable for this kind of new paradigm where during inference time. One one is that because it doesn't scale quadratically and scales linearly, to us spending additional tokens is significantly cheaper in terms of inference. So this means it can do that process respectively. Another thing that is rather interesting because it's a state-based model is that it actually changed the way you and this is not even deployed on our API because it's not something that people are used to yet, but it's something that we're experimenting with. It can change the way you handle prompts. For example, I could, let's say, have do a single set of forward pass on all my documents several times so that the model learn the documents, residue memories of it, and with certain set of prompts, and I save that state. So this is so you can view. So then I do the next prompt from that state. That means every subsequent inference, right? My state, right? The state that I have trained, to call it training might not be the right. Like that I have pre-prompted, is now part of the model memories somewhat. Then I can just prompt from there, and so this is kind of like something that that will benefit like kind of like this kind of inference paradigms. There's also another technique which we are still working on, right? That is once again unique to RWK because we have all these fixed states that we start with. Is that another thing that we can do is we can take data from the data sets and we do fine tuning. But instead of fine tuning the model weights, we fine tune the state, and this state is 400 megabyte depending on model size and how we design it. And when we do inference, right, we start with that state. So this is a very it's not the same thing as LoRa, but it's another form of lightweight fine tuning that can
Mhm.
be done at near inference time essentially.
Yeah.
And those are techniques that we are exploring further to actually push these paradigms respectively.
So the state in this case is what moves from one token to the next one, right?
Yes,
And yeah, effectively saying that the initial state is also now a model parameter
exactly.
that can be trained. Yep.
And it's a very small parameter in the large scheme of the billions of parameter, but it's very important for the model and it's very
Mhm.
effective to train it.
Yeah. Yeah. And I like how so it also potentially opens the whole area of investigating. Maybe again that's what you meant, right? But you can run multiple prompts, get multiple states, and potentially find a way of mixing them
Yes.
in some way. Yeah.
Yeah,
Okay.
we are still scratching the surface of understanding how our states work. Every
Yeah.
time we barely understand how one of our version state works. That was 2 versions ago.
Yeah. Okay. So I guess one other interesting question is this is effectively a non-profit effort under Linux Foundation, right? Or that's not quite the case.
Say again?
So this is the project is done under Linux Foundation, right?
Correct. So the
Yeah.
RWKV project is under the Linux Foundation, and that means all the core RWKV code, IP, and all that is under the Linux Foundation. So this provide assurance that our commitment to the open source side of things. Like even if let's just say hypothetically, me or other key members go completely rogue and closed source and stuff like that, Linux Foundation holds the IP for what has been released to date, and they will continue maintaining. They'll be able to continue maintaining the project, and we did that because rather we actually had lengthy discussion of it internally. Like, do we come up with complicated board structures, open source structure, and it's like what happened to other AI groups, and we're like, why don't we just use this very old fashioned, tried and tested Linux or Apache Foundation kind of structures, and it's like, yeah, why don't we do that? And then we went ahead with it because it's reliable in assurance.
Mm-hmm. So I guess an interesting question here is, you also, besides RWKV, you run a for-profit company, right? So how do you balance your time commitments between the two?
So at the end of the day, right? So RWKV's key mission is to make AI accessible to everyone, regardless of language, nation, or compute. And these open source models are the path forward. So when we decide to create a corporate entity to support the open source movement, we looked into the history of open source, what worked well, essentially. And one of the key shining example of so there are different structures, like there's like the support structure, so you provide support services. But I think one of the key big shining example for us was the database. And database had multiple decades of trying to sort this out. And like, for example, like MongoDB, Atlas, Elastic, and a few others, they have an open core model where essentially any of us can run the database. But running databases is not so easy as well. Like there's setup work, maintenance work, all that. So a lot of us end up just running the platform instead. And so the commercial arm benefits from hosting the databases, be it in the public cloud, private cloud, or on-premise. But the database itself is open. And as long as we are able to like balance that respectively, we will be able to help essentially monetize these models. And so we decide when we build the commercial arm, which is right now Featherless AI, we decide to move in that direction, where we provide inference and manage inference support for any open source model, not just RWKV. Even though it started with RWKV, we actually expanded to even non-RWKV models, and that essentially becomes our revenue line for that help us sustain the open source business, and it also keeps incentive in line. So for us, at the end of the day, right, the real customer question is, are they going to use OpenAI or one of the open models, be it Llama or us? And as long as we keep supporting the open source community to make better open models, then they are more likely to actually do their inference on Featherless instead of, let's say, OpenAI or Anthropic Cloud or Google, and that in sense gives us additional revenue, which then feeds back into us supporting the open source community. So it makes the company align to that common goal as well, and that's how we balance it in between. If you want to say like the more specific, how's my time balance? Oh gosh, I wish I got I know how I even juggle my time on this. But yeah, I would say like 30 to 40% is like me just juggling all the research initiatives or getting the GPUs for the open source research, and the rest of my time is just juggling managing the company to just scale the inference and get more customers.
Yeah, sounds exciting. So yeah, for everybody who wants to find out more, the website is rwkv.com, and yeah, it already has all the diagrams for the future version and a lot of details from the previous ones. So yeah. check it out. And thanks a lot, Eugene, for joining us today.
Yep. And yeah, have a good day ahead.